Good day. Today we are going to focus on the trigonometry. So the word trigonometry, it comes from the Greek word that is called trigon. The trigonometry, it comes from the word trigon, which means the measurement of the triangles. So actually, in a trigonometry, we are focusing on the measurement of the triangles. That's all. Trigonometry, we're just focusing on the measurement of the triangles. Okay, so I want us to focus on the right angle triangle. I want us to focus on the right angle triangle. So I think you have learned before um, things about the right angle triangle. So let's say that this is our triangle, it is A, B, C. So what do we know about the right angle triangle? What we know is a side that is opposite to 90 degrees squared, so AB squared, is equal to other two sides squared. So it's equal to AC squared plus CB squared. So the first thing that we focus on the right angle triangles, it is the theorem of Pythagoras. So this is the theorem of Pythagoras. You're saying that the side that is opposite to 90 degrees is equal to other two sides squared. Okay, so and then another thing that you should learn about the right angle triangles is that a side that is opposite to 90 degrees is called the hypotenuse side. Hypotenuse side. A side that is opposite to 90 degrees is called the hypotenuse side. And then, so this one is A, B, C. And then other two sides, they are going to depend on the fact that which angle are you talking about. For example, if we are talking about the angle B, it is going to mean that the side that is opposite, it is AC. This one is the opposite side. So therefore, this one is going to be the adjacent side. But then, if we are talking about, so this is A, B, C. But if we are talking about angle A, the side that is opposite to angle A is CB. So this means that this is going to be the opposite side. So the opposite to 90 degrees is the hypotenuse side. Then this one is going to be the adjacent side. Okay. So actually in grade 10, what we focus on the most, it is the trigonometric ratios. So we have what we call the trig ratios. We have what we call the trig ratios that we focus on. So what we do is we use the trig ratios to determine the relationship between the sides of the right angle triangle. We use the trig ratios to determine the relationship between the sides of the right angle triangle. Okay, so the first trig ratio, which is called the sine, the next one is called the cosine, and then the next one is called the tangent. So we use them to determine the relationship between the side of the triangle. Okay, so the first one is called sine. So sine is defined as the opposite side over the hypotenuse side. And then cosine is defined as the adjacent side over hypotenuse side. And then tangent is defined as the opposite side over the adjacent side. Okay, so let's use an example. Let's use an example. Let's say that, for example, we are given a triangle. This is a triangle. A, B, C. Okay. And then we are told to find sine B. So sine is opposite over hypotenuse. So we know that the hypotenuse side is the one that is opposite to 90 degrees, which means that in this case it is AB. This is the hypotenuse side. Then above is the opposite side. So because we are talking about angle B, this means that the opposite side is AC. Right? Now, what if we're saying that sine A? Sine A, now we are talking about this angle. So we always know that the hypotenuse side is the one that is opposite to 90 degrees. In this case, it's the same one. And then now, because now we are talking about angle A, this means that the opposite side now is BC. This is the opposite side. Okay. Now, let's talk about the cos. Cos B. Cos B. So now, right now we are talking about this angle B. So always the hypotenuse is opposite to 90 degrees, right? So in this case, that is AB. Already this sine is a sine of 90 degrees. And then adjacent. So this one is opposite. So obviously this one is the adjacent one. This one is adjacent to angle B. So it is BC. And then cos A. Cos A, we are not talking about this one. So in this case, obviously, the hypotenuse is always the same. And then we are talking about angle A. So this side AC, it is adjacent to angle A, this side. So AC. And then now we are talking about the tangent A. Tangent A. So if you're talking about tangent A, so we're talking about this angle. So according to this angle, the side it is opposite, it is BC, right? So what is tan? Tan is opposite over adjacent. So here, the side it is opposite, it is BC. And then the adjacent one, adjacent to A is AC. And then tan B. So now we're talking about this angle. So the side it is opposite to B is AC. Remember, tan is opposite or adjacent. So the opposite side is AC. And then the adjacent side, it is BC. So that's the trigonometric ratios. Okay. Let's look at some formal examples. Let's look at some formal examples that we can use. So let's say this is our triangle. This is our triangle. Triangle D E F. So this is beta, and then this one, let's say this one is theta. This is 12, and this is 5. Okay, and then let's say we are told, number 1, find DF. How do we find DF? So what do we know about the right angle triangle? We know that the side, the longest side, the one that is opposite to 90 degrees, is equal to other two sides squared. So meaning that we can say that DF squared is equal to EF squared plus DE squared. So we are looking for DF. So EF is 12 squared, and then DE is 5 squared. So 12 squared plus 5 squared, it is 169. So because we are looking for DF, not DF squared, we need to cancel the squared using the square root. So therefore DF is equal to 13. So DF is 13. And then number 2 says right, cos theta, sin theta, and tan theta. Okay, what is cos theta here? Theta is this one, right? So what do we know about theta? Theta is the adjacent over the hypotenuse. So we're talking about this one, I guess. So we know that the hypotenuse is the one that is opposite to 90 degrees. So in this case, the one that is opposite to 90 degrees is 13. So meaning that it's going to be below 13 because it's adjacent over hypotenuse. And then the adjacent one, which side is adjacent to theta? Is this one, EF, which is 12. And then sin theta is opposite over hypotenuse. So the opposite side to theta is 5. And then the hypotenuse one is 13. And then we have tan theta, which is equal to opposite over adjacent. So tan theta, the opposite one is 5 to theta, and then the adjacent is 12. And then number 3, write sin theta. So what is sin theta? Sin theta is equal to, so we're talking about this side now. Sin theta, we're talking about this side. So we know that sine is opposite over hypotenuse. So in this case, the opposite side to beta is 12. And then the hypotenuse, the one that is opposite to 90 degrees, is 13. And then we have cos beta, this one. So it's equal to, so we know that cos, it's adjacent over hypotenuse. So the adjacent side is 5, and then the hypotenuse is 13. And then we have tan beta. Tan beta, it is opposite over adjacent, it is equal to, So beta is this one, so the opposite side to beta is 12, and then the adjacent side is 5. So those are the trigonometric ratios. Those are the trigonometric ratios. Okay, thank you so much.